If you examine Chapter 5 of Professor Richard Boateng's text, Information Technology Policy and Strategy, you find a rigorous breakdown of how institutions plan for their digital futures. Budgets for hardware upgrades, software licenses, or server replacements typically characterize an operating plan, but strategy defines the true architectural alignment. It specifies exactly how technology will structurally enable an entire enterprise to win. Transforming theoretical business goals into deliverable digital assets requires a specific structural framework. You cannot buy a competitive advantage. You have to engineer it. To understand how these frameworks are built, we are going to deconstruct the actual strategic plans of real-world institutions, evaluating 4 distinct models. The line dividing a failing IT department from a successful one is the presence of an actionable, measurable enterprise blueprint. This diagram represents Gartner's IT strategy template. It serves as the industry-standard mental model for organizing strategic priorities, splitting IT strategy into 3 distinct pillars. The first pillar is demand. This establishes the business context, defines what business success looks like, and identifies the exact organizational capabilities required. The second pillar is control. This dictates the IT principles, governance structures, and rigorous financial management required to oversee the operation. The final pillar is supply. This governs the actual execution, the specific IT services provided, the enterprise architecture deployed, and the human capital hired. Any functional IT strategy, regardless of the institution, must successfully balance demand, control, and supply to be viable. Demand is the necessary starting point. The IT department cannot meaningfully contribute if the overarching goals of the business remain ambiguous. Control is the mechanism that ensures the strategy actually comes to life, translating theoretical goals into tracking metrics. We can see this balance in our first real-world case study, Stanford University's IT Services Strategic Plan. Stanford outlines a massive operational demand rationale. They must support the complex computing needs of a multi-campus, world-class global research institution. That high-level demand directly dictates their required client services. For Stanford's users, the expectation is untethered, seamless access to applications and data from any device, 24 hours a day, 365 days a year. To manage the corresponding supply, Stanford splits its strategy execution into 2 distinct timelines, tactical and strategic. Look at their current roadmap on the tactical track. This focuses on immediate infrastructure fixes, primarily increasing wireless network capacity and unifying communications. This includes a specific tactical push to treat mobile devices as first-class citizens, ensuring they are fully secure and integrated. They also mandate an immediate migration to cloud-based collaboration tools to realize energy savings and drive down operating expenses. Moving to the future roadmap, the strategy transitions into a long-term architectural transformation. This includes plans to implement multiple tiers of authenticated access, managed entirely by strict centralized identity protocols. The long-term physical supply chain completely shifts. Their goal is to establish elastic, geographically diverse storage models that will entirely eliminate the need for local on-campus server rooms. At the same time, they identify the future necessity of constructing a specialized research data center built specifically to handle extreme high-density modeling and data analysis. Stanford's strategy focuses on adapting its technological supply to meet the ever-expanding mobility and research demand of its academic community. Moving to the University of North Carolina at Charlotte, we find a highly contrasting approach to strategy building. Where Stanford prioritizes user capability roadmaps, UNC builds its foundation on rigorous environmental scanning and control metrics. UNC's executive summary establishes 6 core departmental goals, centering on reliable systems, cost-effectiveness, and technical innovation. Before they outline how to achieve those goals, they execute an environmental scan. This is a process of looking outward to assess external, disruptive technological changes. The university identified specific external factors reshaping their landscape: the rapid rise of consumer technology, the dominance of social media, and the growth of mobile computing. They also tracked a structural industry shift moving away from institutionally owned hardware and towards software as a service and widespread virtualization. Identifying these external factors forces the institution to alter its internal structural priorities in response to outside reality. To manage this reality, UNC asserts control through a strict operational matrix. Let's look specifically at how they structure goal number 1, reliable and secure systems. Under action plans, the strategy mandates fully implementing high-availability technologies and modernizing the network delivery. The effectiveness measures column mandates tracking the specific annual decrease in unplanned system outages. They tie these actions directly to capital. The resources required column explicitly budgets $12.5 million specifically for the network replacement project. Finally, the plan assigns direct personnel accountability. It names the vice chancellor and the chief technology officer as responsible. UNC's model is a masterclass in Gartner's control pillar, ensuring no strategic goal exists without an assigned metric, an allocated budget, and an accountable owner. For organizations with no existing strategic framework, Baylor University provides a generic, baseline plan for nonprofits, proving how scalable this architecture is. The foundational step is the overview and introduction. This defines the overarching organizational mission and formally designates the members of the IT planning team. This is followed by an organizational analysis phase, where current business processes are mapped out through detailed flowcharts or operational tables. Strategy requires explicit justification. The organization must identify why specific processes need improvement and dictate how technology will facilitate that change. Only after that analysis is complete does the plan move to the final phase: technology improvements and acquisitions. Here, the plan mandates 3 outputs: an inventory of required hardware and software, a dedicated overall IT budget, and specific metrics to measure success. Even in its most generic form, an IT plan mathematically links current business realities to future technology acquisitions. Stanford's user-centric roadmap, UNC's data-driven environmental scan, and Baylor's generic baseline all illustrate a central theme. If we bring the Gartner framework back, we see that all these disparate approaches are governed by the same underlying physics. Every plan must first capture the demand. Institutions have to translate high-level academic or business missions into tangible technological needs. Every plan must institute control. They have to use rigid metrics, environmental scans, and financial accountability to keep the execution grounded in reality. And every plan must ultimately provision the supply. This means delivering the actual cloud architectures, secure networks, and support services to the end users. A successful strategy transcends immediate tactical fixes. It forces an institution to continuously analyze the environment and anticipate future disruptions before they occur. The enterprise IT strategy serves as the definitive blueprint, aligning technological investment with the organization's ability to survive, adapt, and win in a digital environment.